Welcome to our revision summary on displacement reactions. So first thing we actually need to understand before we look at these displacement reactions are those two key patterns in reactivity that we've seen as we've looked at group 1 and as we've looked at group 7 in our previous lessons. So in group 1, those alkali metals, the further down the group you go, so as we go down the periodic table from the top towards the bottom, then we find they become more reactive. Whereas in group 7, which are our halogens, the further down the group we go, the less reactive they become. So what we need to understand then is when we're thinking about our group 7 elements, then they can actually react with metal halide solutions. And remember, a metal halide is just one of our alkali metals joined with one of our halogens. Now, what we're actually talking about when we refer to a displacement reaction is where our more reactive halogen will displace a less reactive halogen from the metal halide solution. What we've got in the table there then is the actual experiment results that you should have got when you did this practical in class. And at the bottom of the picture there that you can see are the actual results that hopefully you did see. So what we did in our experiment then was that we took our 3 different solutions of metal halides. So we had sodium chloride, we had our sodium bromide and our potassium iodide. Then what we did was we added our chlorine water, bromine water and iodine solution to those 3 different chemicals. And all we did then was we had a look to see if there was a colour change. If there was a colour change, we had a reaction. If there was no colour change, we had no reaction. And as we can see, if we look at the little picture of the spotting tile at the bottom there, we can see on that top row, which is our chlorine water reacting with our 3 different metal halides, our first one where chlorine water was reacting with sodium chloride, didn't change, it stayed that colourless colour. And that's down to the fact that if we're reacting chlorine with something that contains chlorine, clearly neither is more reactive, so we don't see any change there. In the middle one on that top row, that's our sodium bromide and chlorine water. Chlorine is more reactive than our bromine. So that means that chlorine is going to take the place of bromine in that metal halide solution. And you can see there's that slight colour change in that one. When we look at our chlorine water with our potassium iodide, then chlorine is more reactive than iodine, which means that the chlorine takes the place of the iodine in the potassium iodide to make potassium chloride instead. And we can see that's happened because we've got that very clear colour change. And as you look down the other rows, you can see that our bromine water has only reacted with the potassium iodide, whereas on that bottom row where we had iodine solution, there's no change. They've all stayed the same colour as the iodine solution. And that's because our iodine obviously won't react with itself. The bromine and the chlorine are more reactive than iodine. So that means that the iodine can't take their place in the metal halide. From those experiment results that we generate, we can actually put together a reactivity series, which is what we've got in the bottom right there. So our most reactive halogen is fluorine and our least reactive is astatine. And just remember that if we've got one of those halogens that's more reactive than another one that's in that metal halide, then the more reactive one takes the place of the least reactive one. We do need to know how to write the balance symbol equations for these reactions. So on the top row we've got our general equation. So X and Y are going to represent our 2 different halogens and M is our metal there. So X2 plus 2My makes Y2 plus 2Mx. Now remember, this is only going to be the case if X is more reactive than Y. Okay, and to give you an example of where we'd see this, what we have there, we've got chlorine reacting with potassium iodide. So Cl2 plus 2Ki is going to make I2 because chlorine is more reactive than iodine, so it's going to take its place in the metal halide, and 2KCl. Okay, so all we've done there, because our chlorine is more reactive than the iodine, then it just takes the place. So all we do is we just swap the places of our chlorine and our iodine. So if you think back to what we've done previously, we've looked at what an oxidation reaction is. So the other side to that is a reduction reaction. So again, we've got our little acronym there of oil rig. So if you remember, oxidation is loss of electrons and reduction is the gain of electrons. And that's what we're concerned about when we're thinking about our displacement reactions and our group 7 elements. So with group 7 elements, then they've all got 7 electrons in their outer shell, and we know that because they're in group 7. So what we actually find then is they will gain an electron to give them the full outer shell. So because they've gained an electron, we know that that is a reduction reaction. You might be asked to write an ionic equation for one of these reactions. So at the top there we've got the general ionic equation. So X is representing our halogen and E minus represents our electron. So X2 plus 2E minus gives us 2X minus, because each of our halogen atoms gains 1 electron, giving them 1 more negative charge than positives, which means we have 2 single negative charged ions being formed. So to put that into context with actual chemicals this time then, if we have a look at chlorine. So our chlorine goes around as a pair, so we've got a Cl2 plus 2 electrons, gives us 2 chloride ions, so 2Cl minus. One thing to remember is that when we're thinking about the reactivity, the easier it is for our element to gain an electron, the more reactive it is. And the way that we know if it's going to be easier to gain it is based on the position of the outer shell in comparison to the nucleus. The closer that outer shell is to the nucleus, then the easier it is for that electron to be gained, so the more reactive it is, which is why as we go down group 7 then it gets less reactive, because the further down group 7 you go, the more electrons there are, so we've got more outer shells, and the furthest point will be obviously a long way from the nucleus, meaning it's going to be harder to gain that electron, making it less reactive.